All right, let's jump right in. We're going to talk about some truly groundbreaking technology today. The kind of stuff that translates our body's own electrical signals into real-world action. Seriously, we're talking about controlling machines with nothing more than a glance.
So think about that for a second. What if a simple blink could change a life? Now, this isn't just some far-off science fiction concept. It's actually at the very heart of the technology we're exploring today, a system that's designed to give back control and independence to people who've lost it.
You know, it's easy to take for granted this simple act of moving around. But for people with severe motor disabilities, the world can feel incredibly limiting. Everyday things, just getting from one room to another, or interacting with your surroundings, these can become huge daily challenges. And here's the real kicker. It's not a lack of will or thought. The intention, the desire to move, it's all there, in the mind. The problem is a disconnect, right? A break in that chain of command between the brain's instruction and the body's action. So the big question is, how do you rebuild that bridge?
Well, it turns out the answer is already inside us. Our bodies are fundamentally electric. Every single time a muscle tightens, a nerve fires, even when our eyes just dart from one side to the other, all of it generates tiny, measurable electrical signals. You can think of them like these little electrical whispers our bodies are making all the time. The trick is just learning how to listen in.
And these whispers have a name, of course. They're called biopotential signals. It's basically the language our biological systems use to communicate. And it's this exact language that scientists and engineers are now tapping into to create these unbelievable new ways for us to interact with computers.
Okay, so there are a couple of different signals we can listen to. EMG, that's electromyography. It picks up on muscle activity. But the system we're focusing on today uses something called EOG, or electrooculography. And what that does is read the electrical signals created specifically by our eye movements. Now, why the eyes? Well, this is absolutely crucial. For many people with severe motor impairments, the ability to control their eye movements is one of the very few voluntary actions they still have complete control over. It's a reliable channel when others are not.
And this brings us right to the solution, a human-computer interface in HCI that is built specifically to listen to those eye movements. It's basically a high-tech bridge that turns a person's intention, a simple look, into a direct command that a machine can understand and act on.
So let's pop the hood and see how this bridge is actually built. First, you've got the signal acquisition part. That's what reads the EOG signals from the user's eye movements and blinks. Then that raw data gets sent to a powerful software interface, in this case a MATLAB GUI, which does all the heavy lifting of processing it. Next, these really cool little things called Hall effect sensors take that processed signal and turn it into a clean command. And finally, you have the robotic vehicle that gets the command and moves. Every single piece has to work perfectly.
Now, if this whole setup has a brain, it's definitely the MATLAB GUI. This thing is the master translator. It takes all that noisy electrical data coming from a glance and figures out, with incredible precision, okay, was that a look to the left, was that an upward glance, or was that a very deliberate blink? It's a smart filter that makes sense of it all.
But a brain needs a way to send its messages, right? And that's where the Hall effect sensors come in. They're the messenger. Once MATLAB has made a decision, these sensors act like a perfect little digital switch, converting that decision into a clear, unmistakable electrical instruction that the robotic vehicle can understand instantly.
So we've seen all the individual components. Now let's put it all together and see how this becomes a smooth, seamless flow. Because the real magic here isn't in any one part, but in how they all work together in a split second to turn a simple look into actual physical motion.
And here it is, the whole process in 4 simple steps. It's like a beautiful little dance. Step 1, the user looks or blinks. Step 2, electrodes on their face capture that signal. Step 3, the MATLAB software deciphers what it means. And step 4, a command gets sent and the vehicle moves. It's like a biological joystick, controlled entirely by your eyes. Just amazing. Okay, this brings us to what is, for me, the most important part of this whole story. The technology itself is fascinating, for sure, but its real power, its true meaning, is what it does for people. We're not just talking about moving a gadget around.
Now, this is so much bigger than that. This is about restoring a sense of agency to someone. It's about boosting their autonomy, their ability to make their own choices, and interact with the world on their own terms. It's about connection. It is fundamentally about improving a person's quality of life. And this quote from the research, man, it just says it all, doesn't it? provide them a certain level of movement independence. That's the goal. That's the whole reason for all this incredible science and engineering, to give back a piece of the world that had been taken away.
So that really leaves us with a powerful, kind of mind-bending question for the future, right? We are just scratching the surface of learning to understand and translate our body's own secret electrical language. As this tech gets better and better, what other kinds of conversations are we going to have between humans and machines? What other incredible abilities are we about to unlock?